Hi, I'm Jonathan. I'm a student here at Florida Gulf Coast University in the College of Engineering, majoring in civil engineering. Also, one of the challenges was to minimize the weight of your bridge. So your score, you were scored how well you did based on a ratio of how much your bridge weighed to what was the uh, how much the bridge weighed to what load it could produce. Um, and once we designed and built the bridges for class, we came in and everyone had to test their bridges and see how they performed.
To build a bridge.
Well, we had to use a truss design, a truss structure, which specifically means it's all two force members, as opposed to if I build a bridge that was just a flat plank of wood and I put a load in the middle, the wood would want to bend like this because there's a lateral load on it. A truss structure means all the members are either in tension or compression. So we had to use a truss structure, and then we had different options as far as there's different names of different trusses. I believe my design, my team was a Howe through truss is what it's called. So
And how did your team do? Did you do?
we were kind of in the middle of the pack, which was disappointing. We worked hard on it, but the thing we learned was that in addition to not wanting the bridge to collapse, if I'm looking at the bridge this way, our bridge tended to want to twist this way. So we should have applied some cross bracing, which that was a good part of the project, which it showed you obviously importance of building prototypes of anything and testing it, because things you may not have anticipated begin to happen, and then you can improve your design. So if we were to redo our design, we would change it that way to provide cross bracing so it wouldn't twist under load.
How much load did your bridge hold?
Our bridge held about 9.5 pounds, and it only weighed less than an ounce. It actually weighed about 6/10 of an ounce, and it held up 10 pounds, which is pretty impressive. So,